Here we have our Module 4 class notes example 2, another rational function to graph, to find the characteristics of. Once again, if you haven't watched the example 0 intro example video, please do so. And taking off from there, from that explanation of all the characteristics of a rational function, we'll come back here and let's talk domain, intercepts, asymptotes, and putting all that information together to sketch the graph of this function. First of all, it's always a good idea to factor both the numerator and the denominator of a rational function. Doing that work up front gives you just a head start on all the pieces of information that you're going to have to find and put together to sketch the graph of this function. I recognize that in the denominator, x minus 4 times x plus 2 is a correct factorization of that trinomial. And then in the numerator, x squared plus 4, that is a sum of two squares, and you can't factor a sum of two squares. So there's no factoring x squared plus 4. We then have factored as much as possible. And now we're ready to, let's say, start with the domain, finding the domain. And now it's easier to find the domain because we know the domain, that's where the denominator can't be 0. So it's easier now that it's factored to say x minus 4 can't be 0 and x plus 2 can't be 0. So x can't be 4 and x can't be negative 2. X can be anything smaller than negative 2. It can be anything bigger than 4, and it can even be anything between negative 2 and 4, but it just can't be negative 2 and it can't be positive 4. So the union of these three intervals gives us our domain of the rational function. Next up, let's look at intercepts of this rational function. The y-intercept we find by letting x equal 0. And we can plug 0 into either the factored form or the original form. I find it a little easier to plug the x value of 0 back into the original form because then everything kind of zeroes out. And I've got just 4 over negative 8 left when I ignore all the zeros. And so when x equals 0, I get 4 over negative 8 or negative 1/2. And my y-intercept is 0, negative 1/2. For the x-intercepts, we set the output to 0, we set the y value to 0, and like we said in the previous example, that boils down to just setting the numerator equal to 0. Except in this case, x squared plus 4, if we try to set that equal to 0, there's no x value that works there. None. If we tried to solve, we would subtract 4 on both sides and get x squared equals negative 4, but you know as well as I do, you can't square a number to get negative 4, so there are no x values that satisfy that equation, meaning there are no x-intercepts, and that's okay. There's nothing wrong with that. That's just a characteristic of this graph, no x-intercepts. Next up, we'll take a look for asymptotes. And like we've seen before, the vertical asymptotes, those are those lines that the function is approaching but never touching, given here again by the domain restrictions where the denominator is equal to 0. That's those x values that our function is going to never quite reach. And so setting x minus 4 equal to 0 and x plus 2 equal to 0, we get x equals 4 is one equation of a vertical asymptote. And x equals negative 2 is another equation of a vertical asymptote. For the horizontal asymptotes, or not plural, for the horizontal asymptote, singular, we once again compare the degrees of the numerator and denominator, which are 2 and 2 here. And we see the numerator degree and the denominator degree are equal to each other. And so we set up the horizontal asymptote as the fraction of leading coefficients 1 over 1. 1 over 1, y equals 1 is my horizontal asymptote. Now we put the asymptotes and intercepts all together, all the information that we found so far. Y equals 1 is my horizontal asymptote, x equals -2 and x equals +4 are my vertical asymptotes. And then I've got the only point that I know so far, 0, -1/2. And I seem to have extrapolated quite a bit of the curve from that one point and these asymptotes. So from that one point, 0, -1/2 here, what I've concluded is, and if you're not as comfortable, if this is your first look at rational functions, feel free, plug in more x values. Plug in as many x values as you want to put more dots on the graph, to connect the dots. There's nothing wrong with that at all. But I can use logic here to say that from that one point that I know, my graph is going to approach my asymptotes, my vertical asymptotes, and never quite reach them, certainly not cross them. And I also know that I have no x-intercepts. Remember we concluded that? I have no x-intercepts. So from this point 0, -1/2, I can't turn up and move through the x-axis. I already determined that I have no x-intercepts. That tells me then that I must turn down. If the x-axis is if I can't cross the x-axis because I don't have any x-intercepts, then I really don't have a choice except to turn down and for my graph to open down in both directions and get this kind of almost parabola curve going here in the middle of the graph. Sorry. No, can't. Okay, let me erase that. This parabola curve happening in the middle of the graph. But again, if you don't see that, then just plot some more points. Use some more x values to find some more y values and make sure that you can connect the dots to make sense of the way this curves. But also realize that we don't have any information out here or here. We need to fill in these big gaps in the graph, and we can do that by, like I just said, picking some x values, finding some additional points. So let's pick an x value, say -3 on the left, and pick another x value, say +5 on the right. Plug those in and see where my points land. When I use x equals +5, here's what I get for my result. You should be able to follow that and find the output, 29/7, which is a little more than 4. So when x is 5, y is a little above 4. And then when I use -3 to find that additional point, I get a y value of 13/7. So when x is -3, y is 13/7, which is a little less than 2. Plotting those points and using those points and asymptotes to shape the other curves on my function, then I see with an x value of 5 and a y value of around 4 here, my graph is going to curve toward both the vertical and horizontal asymptotes, and I have this curve shape on the right. Similarly, on the left, an x value of -3 and a y value close to 2, a little bit less than 2. From that point, my graph is going to curve toward the horizontal asymptote and the vertical asymptote, and I get, once again, stray marks. I get this curve of this in this portion, this branch of my graph, and I've got these 3 branches that all together form the entire graph of my function.